Good morning, fifth grade. It's Miss Fisher here on AMI Day 3. Today is Tuesday, March 16th, 2020. I am currently drinking out of my Mulan coffee mug, so ready to get today started. Okay, so we're going to start with going over the article that I posted yesterday and the article that we were going to go through yesterday, okay? So I'm going to read the article out loud, and then we're going to go through the questions, and you can check along your answers. Everything should be graded by now, so you can go back, look at your score. We did struggle a little bit with this one, so hopefully going over the answers are going to help you to see where you might have gotten the wrong answer, okay? So I'm starting at the top. You can read along with me if you would like. Clouds in the sky can look like rabbits, bears, and lions. They may even look like people. These clouds are made of water and ice. Much farther away, other clouds are scattered through outer space. These clouds are not made of water, but like the clouds in the air, they can also make familiar shapes. In fact, one space cloud looks like a horse. Now, astronomers may have found out why it has that shape. The cloud is spinning, okay? And our next section is called a giant game piece. So ask yourself as you're reading, okay, a giant game piece, that's the title of our next section. What do I think this section is going to talk about? Okay, when I see a giant game piece, I'm going to say that maybe this section talks about what the space horse does, what the space cloud does, okay? This cloud is the Horsehead Nebula. Nebula is a Latin word for cloud, so Horsehead cloud. It looks like a black knight in a chess game. Okay, so giant game piece, that's where we have that. It's eerie, and if you scroll over number 1, we know the definition means strange or mysterious. So it's eerie and haunting, one of the most famous clouds in space. Like other space clouds, the Horsehead Nebula is made mostly of hydrogen and helium gas, the two lightest and most common elements in the universe. These glasses are clear. Light goes right through them. So why is the Horsehead black? Dust particles made mostly of heavier elements pepper the clear gas and block visible light. The gas and dust in the Horsehead Nebula do not make any light that your eye can see, but the gas makes radio waves, which we can detect using special telescopes called radio telescopes. You can't look through a radio telescope the way you would look through a normal telescope. Instead, the radio telescope is a giant dish-shaped antenna. Okay, so that paragraph got to stop there. Even for me, that's a lot to take in. That's probably somewhere where you would naturally stop and use that ask and answer strategy. So I would stop here and say, all right, let me figure out, make sure I know what's going on. So we're talking about the radio waves and the radio telescopes in that last paragraph. Okay, so the gas in the Horsehead makes radio waves. Okay, and we can look at these using radio telescopes. All right, perfect. Okay, once you know what it's about, you keep going. In 2003, astronomers in Europe used a big radio telescope in Spain to observe the gas in the Horsehead Nebula. They made a big discovery. They found out that the Horsehead Nebula is slowly spinning. The next section is called Clues in the Waves. So here you can ask yourself, okay, what do I think we're going to talk about in the next section? If I was looking at this, I'm going to say that they're going to tell us how they found out it was spinning. So let's read and find out. Here's how they did it. They observed changes in the radio waves from the Horsehead Nebula's gas. When an object that gives off radio waves is moving toward us, its radio waves get scrunched up a little, so they have a shorter wavelength than usual. Okay, we call this change to shorter waves a blue shift because blue light waves are short. Okay, so now I know they're about to tell me about two different light waves, okay? And you had a discussion question about blue light waves, and now we're about to read about red light waves, okay? So in contrast, when an object that gives off radio waves is moving away from us, its radio waves are stretched out, so they're longer than usual. We call this change to longer a redshift because red light has a longer wavelength than blue light. Okay, so basically, imagine the light waves. If they're scrunched up together shorter, they're going to be blue light. If they're stretched out, they're going to be red shift, okay, red light, okay? So blue is short, red is long. You've probably heard blue shifts and red shifts because sound waves make them too. When a fire truck races towards you with its siren blaring, the siren sound waves get scrunched up, making a shorter wavelength. And we said shorter wavelength was blue. And you hear a high-pitched siren, a blue shift, okay? After the fire truck speeds by, the siren is moving away from you, so the sound waves get stretched out, making a red shift, okay? Making a longer wavelength, and the siren's pitch drops, a red shift. Okay, that's a lot to take in. Make sure you're stopping, asking yourself questions. Compared with the horsehead's neck, the nose has scrunched up radio waves, a blue shift, so it's moving towards us. Part of the horse's mane has stretched out radio waves, which is a red shift, so it's moving away from us. Thus, the horse head is turning. It's as if the horse is trying to look our way. All right, last section is called slowly turning. So take a second to try to figure out what do you think they're going to talk about at the end of this article. Astronomers estimate that the horse will take 4 million years to spin once. Whoa. In contrast, the sun takes just a month to spin and Earth takes just a day. Oh, okay. Interesting. But the Horsehead Nebula is much bigger than the sun or the Earth. Furthermore, the Horsehead spin may explain its unique, and if you hover over unique, that's obviously going to mean different or unlike anything else shape. So its unique shape. To see how, imagine riding a merry-go-round. Now imagine that the merry-go-round started spinning really, really fast. It would fling you off. In the same way, the nebula spin may be flinging out 2 pieces of gas and dust from the horse's neck. One piece has become the horse's nose. The other piece has become the horse's mane. So if the Horsehead Nebula were not spinning, it probably wouldn't look like a horse. Then the nebula wouldn't be famous and you wouldn't be reading this article because it wouldn't exist. Okay. Interesting. After reading that, I would say that this is probably definitely a more complicated text, a more complex text. So just pat yourself on the back if you were able to get through it. That seemed like it was a little above grade level for us. So I'll have to take a look at that. But let's move to the assessment questions, and you can look at your answers. Let me go back. You need to go to your graded work. I am going to shout out those people if I had anyone. I can't remember if I did, but I will shout you out if you made an 80 or above. Okay, so let's start at number 1. Now, these questions were different because some of them had us making 2 choices, okay? So part A says, which pair of sentences provides the best summary of the article? Okay, so we're going to be looking for 2 because it says pair, so we need 2 answers. We're going to be looking for the 2 sentences that really show us what we talked about, okay? The whole article, what the whole article was talking about. Okay, so let's look through A. A, the Horsehead Nebula is a unique nebula because it can be seen unassisted by technology. I don't feel like I can go back in the text. I don't have the evidence to back that up, so I'm going to say A is probably not it. Okay, B, astronomers have determined that the Horsehead Nebula is moving by observing its radio waves. Okay, so we did talk about the radio waves. We talked about blue shift and red shift. So we did talk about how they found out it was moving. So I'm going to say B is a good choice. We're going to say maybe on that one. Okay, C, the Horsehead Nebula is made up of gas and dust that doesn't emit light and can't be easily seen. Okay, that sounds related, but let's make sure our other options aren't, more correct. So D, astronomers aren't entirely sure what the Horsehead Nebula looks like as it doesn't get off light. Well, we know that's not true because we know that it looks like a horse, like a chess piece. Okay, so D can't be our answer. E, the Horsehead Nebula is named for its movement rather than its resemblance to a horse. Well, we know that the Horsehead Nebula spins very slowly. I don't think that's related to the movement. And we know that it looks like a horse, and that's why it's called a horse. So E can't be our answer. And F, astronomers are curious to see what the Horsehead Nebula will turn into as it continues to move and evolve. I don't think F, I don't think there's any evidence to go back. I can't point to any evidence that says that that's what they're looking for. So your answers are going to be B and C. Okay. Let's see. I can't see who 33% of us got that correct. So, okay, now we always have to have that text evidence. Common Lit is all about text evidence. So, part B. Which two details from the text support the answers to part A? So if part A, you're going to have to go and make sure they connect. Okay, so part A, we need to make sure we have evidence about the nebula moving through radio waves and the Horsehead Nebula being made of gas. So A, much farther away, other clouds are scattered through outer space. These clouds are not made of water. Pretty irrelevant. B, so why is the Horsehead black? Dust particles made mostly of heavier elements pepper the clear gas and block visible light. Okay, yeah. So B, we're going to put a B, maybe by B. C, after the fire truck speeds by, the siren is moving away from you, so the sound waves get stretched out, making a longer wavelength, and the siren's pitch drops. A redshift. I don't know. That one's also a maybe. Let's go to D. Part of the horse's mane has stretched out radio waves, a redshift, so it's moving away from us. Thus, the horsehead is turning. Okay, so this one talks about the horsehead moving. So I would say D for sure answer. One of them. And then E. Astronomers estimate that the horse will take 4 million years to spin once. In contrast, the sun takes just a month to spin, and Earth takes just a day. Okay, well, we said... So we already have the connection to B. So astronomers have determined that the horse wave is moving by observing its wavelength. D connects to that evidence. So now we need to find the evidence for the Horsehead Nebula is made up of gas and dust that doesn't emit light and can't be easily seen. And the answer that connects to that answer, to that text, the text evidence that connects to that answer would be B. So why is the horsehead black? Because that text evidence is the only one that talks about, well, why can't we see it? And that was mentioned in part A. Okay. All right, let's move to number 3. Which of the following describes the structure of the information in the text? So this is going to be a craft and structure. So it's not going to be asking you questions like or what happened, what comes first. This is going to be asking you, why did the author make the choices that they did? Okay, so now you're thinking about the author. Okay, how did they write this? How did they set the information up? So which of the following describes the structure of the information in the text? So A, we need to think about how does the author present this article to us, okay? A, the author describes what the Horsehead Nebula is and then what its radio waves have revealed to astronomers. Okay, do I see that? So do I see them describing Horsehead Nebula? Okay, yes. And then go down and there's wavelength. So A could work, okay? B, the author describes how the Horsehead Nebula formed and then compares it to the formation of other nebulae. B, I'm going to say can't be our answer. We have nothing about other nebula forms, and we don't know how it was created. So B can't be our answer. C, the author discusses various nebula and then why the Horsehead Nebula is the most unique. Again, they don't describe other forms. They don't describe other nebula, okay? And then D, the author discusses what radio waves are and then explains how they apply to the Horsehead Nebula. So if you're reading this, some of us probably put this answer because we say, oh, radio waves, we did see that. But you have to think, is that what the author starts out with? Like, these are the radio waves, and then later on, well, this is how they relate to Horsehead Nebula. Okay, so I would say the answer would be A. The author describes what the nebula is and then its wavelengths. Okay, that one was difficult for us, but it's okay. It's okay. We'll get there. All right, number 4. Which of the following describes red shifts and blue shifts in the text? Okay, so this was that part where it was a lot of scientific terminology or vocabulary, and we needed to take a second and reread. Okay, so this one, you're definitely going to want that section pulled up next to it so we can get that text evidence. Okay. Oh, we did better on this one. Good. Okay. So A, they are radio waves that turn different colors. Can we back that up? Probably not. Okay, so A is not going to be our answer. B, they are radio waves that can convey whether something is hot or cold. No. C, they are radio waves of the same length but can convey different sounds. Well, we know that a blue shift is small, shorter, and a red shift is longer. So we know that they're not the same length. So let's read through D. They are radio waves of different lengths that can indicate movement. That sounds like what we talked about. So I would say the answer is D. And it looked like 70% of us got that correct. So much better on that. Okay, last but not least, the short answer. What is the relationship between radio waves and movement? This is probably a more difficult one. This requires a lot of background knowledge. But I'll read to you what a solid answer would be. So students should be discussing how the different lengths of radio waves being emitted from an object can show whether or not that object is moving, and if so, where it's moving. So it's connected because the lengths of the radio waves can show you what direction something is moving. Okay, you could go into more detail and talk about the differences between red shifts and blue shifts, and kind of talk about the lengths there and what they show. It means so that is. I see some really good responses here. And this one was a little harder. Okay, but I see some good ones here. Okay, so that is a new spin on a Space Horse mini lesson. I hope you found that helpful. Hope you didn't mute me halfway through. Okay. While I get your assignment, let me see if there was anyone that got, I don't think there was anyone that got an 80 or above, but I will shout out the people who completed it. Let's see. Okay, so from my first class, like I said, more of a difficult one. I did want to shout out Samaya, Aida, Nikki, and Gael. Thank you guys for logging that in and getting that assignment done. Good job. So I'm just going to shout the people out that did the assignment and see. So moving to my second period. Ooh. Nice. Okay. So the people that got done. I'm sorry. Okay, so first, wanted to shout out Shania. She got an 80%, so good job. That was a really difficult text, so really, really great job there. The other people I want to shout out for getting on and logging time. Hasara, you were really close. You were at a 75%, but that's still really good. This was a harder article. Jada, good job. Suyog, thank you for logging on. Alexis, Matthew, Chris, and Frederick. So good job, second period. Good job. Got a lot of people logged on there. Okay, and then third period. Oh, this is going to be a longer video. Go to grading. Interesting. Sorry, I'm grading these right now. Your scores should be released to you. Okay. Ooh. Ishan, gonna shout you out for getting a 100%. Super good job. I'm super proud. Okay, so other people that came on and logged on, Ankita, good job, Caesar, and Nayeli. Nayeli, you were also really close with the 75%, so good job, everyone. You're now on YouTube, so there's your reward. Okay, so what you're going to do today, hopefully you've made it to the end of this video, but what you're going to do today is I'm going to assign you one more reading passage. Tomorrow's Tuesday, Mondays and Tuesdays, we're going to stick to the same routine. We're usually reading, comprehension, working on the skill. So we're going to stick to that. Wednesday, tomorrow, we're going to do writing. Wednesdays are our writing days. Thursday, we're going to work on grammar. Friday, we're going to do writing. So routine's going to stay the same. So I'm going to assign you another, another article. I know that one was harder, but still got through it. Let's see. The one I'm going to assign is called When Stars Explode. So we're still going to be on this space journey here. This one is also going to be one that's a little more complex, but you got this. Just make sure to use those strategies. Stop, ask yourself questions, okay? Take your time. Anyway, so you're going to do that. The guiding questions will be turned on. You're going to have the assessment. If you need any help with the assessment, I can help out. I'll be having notification on my phone. I'll have my laptop out. And that's what I have for you today. Okay, so I hope that you enjoyed this little school from home video. And I'm super excited for all of us to be back in the classroom together. And I'm excited to hear about everybody's spring break, even though we're all in quarantine, basically. So, anyway, Denny is... Oh, there's Denny. I'll show you Denny. Say hi, Denny. Okay, I promised you I would show Denny today, so here you go. All right, well, I will post another video tomorrow. Let me know if you need anything. Bye, 5th grade.